So now that you understand that the only way that the ram air turbine could have been deployed, the only possible way, you need to understand, well, how can that possibly shut down both engines? The engines have their own electronic computers, the EECs, also commonly referred to as a FADEC, Authority Digital Engine Control, and they have their own AC power, and then it's rectified to DC within the EEC. So it's actually the permanent magnet alternators that are powering it, the PMAs. The power to them is primarily from that, and the only time the power comes from the aeroplane system is if those engines are not running. Okay, so provided the engine's turning, they have their own power. They're completely redundant. There is TCMA, but TCMA requires the aircraft to be on the ground and would shut off the high pressure fuel valves only if the throttles were at idle, and the throttles were not at idle. There's just too many things to say it's not TCMA. It was not the EECs. You can actually rule them out. It's impossible for this to be both EECs at the same time. It's impossible for it to be both at the same time for pretty much anything, unless you can come up with one common central fault. And that's what I've done. This is what I was going to present on Barker's story, on Mojo story, but unfortunately she sort of ran the show and I didn't really get the opportunity to share it. So I'm sharing it now with you. What failed and what functioned as designed? There was only two things really that failed. The diode, which caused the battery to fail. Let's zoom in on that, the top here. In this red box, this is the only real thing that actually failed. So one thing failed a long time ago, the battery diode module, which allowed bad currents, transients and things to really hurt the battery. Other things can also hurt the battery within. They've actually did some tests on the Japanese aircraft in 2013 that suffered the Takamatsu event. And they found that during charging cycles of stopping and starting the charging, there were these transient spikes. And what that is the battery contactor actually opens, either the contactor or the relay or both, opens and shuts. It shuts after charging and closes the beginning of charging so that you're not charging the aircraft. Okay, it wants to know the battery is isolated and it detects what's going on in the battery while it's charging it. And that closing and opening of the contactor and relay has been creating transients. They measured that. So it didn't actually need the battery module to have any sort of damaging transients. They already existed, switching transients on DC. However, worked out the battery diode module was at fault very early on, and then the first thing I did was looked into the battery diode module and found that they were trying to fix it a long time ago, 2024. They were trying to get someone else to make a new one. So you've got some evidence there of them knowing and trying to fix this thing. So what happens? It's shorted long before. It hurts the battery for days, possibly weeks, months. I know it's been hurting it for years, because I know that in 2022 this same thing happened and caused a generator control unit start a contacted unit failure. So what happens? This hurts the battery. The battery eventually gets bad, really bad, and then the sending it to its death is the selection of gear up, which starts the truck tilt sequence, which you definitely saw. You saw the trucks, landing gear trucks tilted, indicating the gear had been selected up, and that starts the auto braking sequence of 7.5% for 20 seconds to stop the landing gear wheels from spinning before they retract. That braking to stop the spinning is powered by the electronic brake power supply unit, which gets its power from both the 28-volt C2 and hot battery bus. There's your source of current that causes the very end of the battery's life. Okay, that goes backwards through the failed diode because the diode is no longer acting as a one-way gate as designed, and it enters the captain's instrument bus. It brings the instrument bus down to whatever voltage the battery is then at. The battery's failing. It wouldn't be exactly 0 volts. It could be, but it wouldn't be exactly 0 volts. It's failing, and what's happened is that voltage has made its way and clamped down the captain's instrument bus, which has brought down the left side instruments in the aircraft, which then automatically closes the first officer and captain's instrument tie breakers to then send that same short circuit across to the first officer instrument bus. And let's just stop here and zoom out, make sure I don't go too far ahead. At the same time, the left and then the right, coinciding with those buses, the left and the right fuel cutoff switches, which do not move. They lose their power due to being exposed to the short from the instrument buses and tell the remote data concentrator that I've lost my on signal, and that makes its way to the flight data recorder, which makes its way to a preliminary report near you. That is what happened. That's how you saw fuel cutoff. Now stop talking about that. It is impossible, because the only way that this could have possibly happened is if the ram air turbine was deployed because of the instruments turning off. The only way. So in parallel to those switches losing their on signal and being recorded as off, the fuel spar valve somehow gets a reverse actuated short circuit induced reverse voltage. Where does that come from? It comes from the battery shorting internally to its case. During the Takamatsu event, the flight data recorder recorded an 11 volt battery voltage out the positive. So that means normally 28 to 29 volts minus 11 volts means that roughly 18 volts went somewhere else. What it did was 18 volts went out through the battery's ground strap and fused the ground strap open in the Takamatsu event. That means you had reverse voltage acting on the ground system. So that means equipment that is close to the battery may have experienced reverse voltage. An item that is close to that equipment that would have experienced reverse voltage powered by the bus, the very bus here, this fuel spar valve relay control, the coils for that are directly powered by the switches from the captain instrument bus. Those coils inside that experienced a reverse voltage through the run switch. The switch is still in run, and the voltage went the wrong way through it and commanded the fuel spars close as commanded by the relay, without the switch ever having even moved. So the switch didn't move, the flight data recorder saw it transition to off. It didn't actually move, which is why they haven't told you that the captain physically switched it, and which is why in the courts they're saying, we never actually said that it's the captain's fault, because they know they'll be done for lying. The fuel spar valves closed as commanded by the relays, and that's why the engines turned off left, then right. Why left, then right? Because the captain's instrument bus and first officer instrument bus took about a fraction of a second to close, so therefore the right happened after the left. The left is directly connected to the battery, the right is not. Now, when both of those went down, that was the immediate requirement for the ram air turbine to deploy. How? Why? Systems Oversight 1, as I've talked about in the Systems Oversight videos. In standby operating mode, when the RAT deploys, with primary electrical power unavailable, regardless of the RAT being actually putting out power through its RAT breaker control, the main battery relay is closed. It's maintained. It's kept closed. Or if it was open, it closes. That's just stupid. Okay, so no matter what happens, regardless of that, the main battery relay is closed, and the instrument buses are paralleled through the closure of those contactors, even if a battery fault exists, and that's exactly what happened. So there you go. The CIT and FIT do close, and even if a battery fault or problem exists. Terrible, terrible design. Okay, System Oversight error number 2. There's a 15-second countdown that happened when all of this started, when the charger unit was detecting that the cells were becoming imbalanced. There was a fault condition. The 15-second countdown began, and here's that 15-second countdown from Hamilton Sundstrand's documentation themselves. This is the protection function. Main battery fault. Detected by the charger unit and sent to the left bus power control unit. Provided that fault condition continues for 15 seconds, it will trip the main battery relay open after the 15 seconds countdown. Bam. That is a massive problem. That's all it took. So everything stayed connected for the 15 seconds, okay, and only after the 15-second countdown was when the battery relay was finally able to open. The battery isolated itself. It burnt through its ground strap, just as it did in the Takamatsu event. And that lines up precisely with engine 1's fuel switch coming back to run and the beginning of the windmilling start, because the fuel valve has opened. This one took 4 seconds longer because it takes 4 seconds for the right BPCU, bus power control unit, to come back online as commanded in air restart mode. Okay, so when that happened, what happens? The fuel spars get their correct voltage because the short circuits let go. Power starts flowing from the ram air turbine through the transformer rectifier unit to create power back again on the first officer and captain instrument bus. That gives us power back, so the captain's instrument bus comes back online again. Okay, and then that sends the correct power to the spar valve and to the switches, which detect it being run. The spar valve moves back to run, opens the fuel valves, and the engine tries to windmill reignite. No VFSG start required. That makes its way through the remote data concentrator to the flight data recorder and to a preliminary report near you. Now, there is absolutely no room for me to be wrong. No room for error. I'm 100% right, and the authorities do have me, and I'm working with the United States fucking Senate. And if you disagree and you want to tell me that your friend flies this thing, well, tell your friend that he's going to lose his 787 soon. Thanks to yours truly. I've been right since the day that I started, and I'm still right, and you are wrong. Thank you.